So welcome everyone. I'm going to first start off by saying welcome to year 4 of the Trees Around the Globe student research campaign. And it couldn't have happened without you. Everyone knows, inside and outside the globe, how important trees are, how important land cover is, carbon cycle, and greenings to, understanding how our planet functions during this time of dynamic change on Earth. So, we've had lots of testimonials that folks at the Global Implementation and Office at NASA heard from you, and we appreciate that. So it really, you know, uh, it's great that we're beginning the year 4 of the campaign, and we are going to be, you know, doing some awesome things this year. We'll talk about that towards the end of the webinar today. Looking ahead to year 4, we have we always like to have some sort of a, different construct for each one of the years, and different, focuses, that play along the lines of what the science is that we're working on, and what where the data is coming from. Whether it be just NASA data or the globe data, and a combination of both. So there's lots of things that we're really focusing on this year. And a little teaser is that we're focusing on, specifically we're having a regional focus of things throughout the months of year 4 of the campaign, that then will tie us into a global perspective of all the observations and measurements, and why they're important, what you can do, and leading up to the IBSS 2022, which we hope many of the students that you teach or work with, and the students that are joining us today will participate in, as far as doing these research projects. And we're going to try to help that along, through the different regions, through the different online tools. And we have our expert, with those, Peter Nelson, who will be talking to you today about it. He'll be doing a little teaser today, about what we're going to be doing, as far as using the online tools to help you look at this data. And, we're focusing on 2 main, tools. And next month, and I'll pop that up in a second, next month, our webinar will really start focusing on, looking at the data, and looking at where the data is coming from, how you can visualize it on using online tools, and really get your hands dirty by looking at that tree height data, that land cover data, globally and in your region. So once again, welcome to year 4 of the campaign. We have a little party favors here, party flags, and the ICET 2 folks are excited about this. We have Paige the Penguin here, on the left side with the party hat on, and part of our logo. So we did this actually for the 3rd year anniversary. We created this logo. So welcome, and let's go. So, I went too far. So, I always like to showcase, some type of tree or trees or areas on the planet, kind of, that relate to the area that we're talking about, during the webinar. And these happen to be the Western Himalayan subalpine conifer forests. And you can see here that they're temperate coniferous forest ecoregion of the middle and upper elevations of Western Middle Himalayas in Nepal, India, and Pakistan. Primarily, they go through the Indian states of Uttarakhand, Himachal Pradesh, Jammu, and Kashmir in northern Pakistan. You can see it's a belt of conifers that basically covers just under 40,000 square kilometers at elevations between 3,000 and 3,500 meters. And we have some folks here from India, including our speaker Yashraj, and we have Desh and a couple other folks here. So they may have seen these forests in person, these Western Himalayan subalpine conifer forests. But I wanted to just showcase this here, because we're going to learn a lot today from Yashraj and his Himalayan expedition. So stay tuned for that. But just wanted to showcase this a little bit. You can see the region is highlighted here on the right side. All right, so today, what we're going to focus on today, we're going to, prior to the feature presentation from Yashraj, Peter Nelson is going to be highlighting Landsat 9, and he's going to be, as I mentioned, focusing a little bit on this teaser, looking at change over time with land cover and tree and forest type for your location, a globe regional focus for year 4 of the Trees Around the Globe student research campaign. And then we will move to the feature presentation by Yashraj, a Himalayan expedition with GISN member Yashraj Patil, looking at the GLOBE program's first high altitude globe land cover, cloud, and hydrosphere data. And before he went, I was talking to him about, hey, you should take some tree height observations, when you're there. He will explain to you why the tree height observations didn't work while he was during his Himalayan expedition. And I won't, steal his thunder there. I'll let him talk to you about that. But he's going to talk to you about this, and he created just an amazing story map. As you remember from year 3 of the campaign, we really focused a lot with story maps. Dorian, brought it to our attention, focusing on the story mapping and a lot of things that she does. She's an expert in the story mapping. Peter Nelson, expert as well, talked about the story mapping and then how to bring that data, specific data from other tools into story mapping. And you'll see here, Yashraj, took all that stuff, learning how to do story maps, and really created a dynamic story map for his Himalayan expedition and the research he was doing there. So we'll talk about that as well. And then what I want to talk about, kind of the end of his presentation, if he wants to lead into that, discussion on, based upon some of the methods that you're going to hear from Yashraj today, some of the methods he used. These are some methods that students can use in their local environment to take observations, kind of, maybe not as grandiose as what, Yashraj did here in the Himalayas, but it's really a great springboard to helping your students understand. So those of you whose students couldn't be here today, make sure you show them a recording of this so they can see those type of techniques that Yashraj used in like some of the GLOBE protocols and why they were important for this location where he was studying. And then at the end, we're going to have a discussion with Dorian. She is going to be introducing us to the Lifelong Learners Program, and basically how we can become involved with a Lifelong Learners Program, how GLOBE students as part of this campaign and, and beyond can become part of what's called with the Lifelong Learners Group. And then we will end today with looking ahead to year 4 and some final discussion. So here's our core campaign team. You know it's all. Some of the metrics here, I'm going to go once again all the way to the bottom. We just started year 4. October 1st was essentially the first, day for year 4, but this is our first webinar as part of year 4. As you can see here, we have full campaign metrics where we have over 40,000 tree height measurements from over 16,000 global sites, over 23,000 land cover measurements from over 16,000 sites, and over 23,000 greenings observations from the students from over 644 global sites. That's a lot of data. Here's where basically all that data is coming from, because this is our map of the active countries for our campaign. These are 58 countries in the GLOBE program, in the GLOBE family, that are part of this campaign, the active members. So where is that coming from? Here is where all the data is coming from. You can see here, there are lots of open spots there where we need more data, but this represents this 85,000 plus measurements from over 33,000 global locations. As you can see here, we've had a bunch of webinars, participants, and we have, lots of blog views from the blogs that are part of our campaign. So the next campaign webinar, just want to announce this, will be Tuesday, November 16th, 2021 at 1 p.m. Eastern Standard Time, which is 6 p.m. UTC. And it will be introducing the Trees Around the Globe 50 Years of Data Challenge. How has land cover and tree height changed in your location in the last 50 years? So we're going to be starting this, and we're having, since we're in the, Asia Pacific region now today, we're going to be, staying here for next month as well, in the region focus for Asia and Pacific, and then we will then move to another, region for the GLOBE program. But what's going to happen here is and Peter Nelson can talk about this a little bit, is that we're going to focus on this and kind of build a cumulative effect of the data coming from these regions, like for instance, Asian Pacific region, and then we add on the next region, and by the time we have the end of the year 4, we will have this really awesome like global map of where where all this data is coming from, and how the land cover and tree height has changed in 50 years all over the planet in these specifically 6 globe regions that are part of the GLOBE program. So that's stay tuned for that, and you'll get an invite to that sometime later today or this week. I don't want to send too many invites out because then some of the campaign things can get confusing with them all coming in. So I'm going to pass this over to Peter Nelson, and he's going to talk to you a little bit about Landsat 9. And I just threw this information up here about when it was launched not too long ago, September 27th, so less than a month ago. It was launched from the Vandenberg Space Force Base. It used to be the Vandenberg Air Force Base, but it's the Vandenberg Space Force Base. It was recently renamed basically several months ago. And it's a continuation of a series of Earth-observing spacecraft which date back almost 50 years. And it continues the program's role monitoring, managing land resources like crops, water, and forest. So, just popping that on here so Peter can start that then. So I don't know, Peter, if you want to show that, but I will pass it over to you and stop sharing.
Thanks, Brian. Would you mind enabling screen sharing? I need some capabilities this morning. And thanks everybody for joining us. I'm really excited to hear what other people are doing in the Globe community with all of these wonderful tools that we have. And as Brian talked about, you know, Landsat data, like what is behind me, is really the foundation of Earth observations. And Globe is a particularly unique organization and group of participants that can really play a unique and special role here. And I say that because, you know, the Landsat missions started back in 1972. So next summer, we're going to be celebrating 50 years of satellite measurements from space. Globe just celebrated its 25th anniversary not too long ago. And so imagine, you know, 25 years worth of data. And we're one of the only organizations that have this. And so we can actually go back into our database and look at old measurements that were made. And because of the wonderful capabilities that are coming because of this new satellite launch, we're going to be able to see a lot more of this data that has historically been a little bit challenging. So we want to actually go back to some of the old Globe lessons that were created with tools like multi-spec and other activities that were built around Landsat, and modernize them, bring them forward into some of the new data that's going to be coming online, as well as all of this wonderful data, like what Yashraj is going to be talking about today, and what he was able to collect in this area. And also the last 3 years of measurements, we can actually start comparing them to some of the data that is out there. And so this is what we really want to start tying together. So I'll highlight, you know, for me, this is an area that I've been focusing on, and I've been doing a lot of data collection. And so you can see that once you start getting a lot of data in an area, you can actually start pulling out interesting patterns and trends. And what's great about this is just from these colors, I hope that you can see some interesting patterns, right? We have white snow, glaciers. We have green areas that are actually trees. We have open areas here that make you wonder what might have happened there, right? And so these photos are really telling. And I really appreciate that Globe has been systematic about putting this database together, because that does make our jobs a lot easier. And what I really want to highlight right now is, you know, that one of the things that we want to start looking at and doing, right, is comparing these sort of measurements to the satellite data and what is actually in these locations. And remember that there is a particular date that is associated with this. And then importantly, there might be some field notes, and importantly, elevation, right? And so, you know, as we start thinking about a changing climate and what has happened over 50 years, elevation is one of those really important characteristics that we can use to ground us and look at a particular pixel at a location and see, is it greening over time? And then hopefully with some measurements, and measurements like what we'll hear about later, you can actually put this photo today in context. And so, you know, we're going to stretch you a little bit to start remembering and thinking about this perspective that NASA is providing to us. And on something like this, you can see all of the constellation of Earth observation satellites that are looking down on us. And here you can actually see Landsat 7 is traversing right down here over the ocean right now. And that is the satellite that it will be replaced by Landsat 9. And so what's nice about this tool that was put together by the Jet Propulsion Lab, hey, this is the instrument that we're talking about and kind of its perspective, right? And so, one thing I want to highlight is this sensor actually broke. Back in 2003, shortly after launch, it had a scan line issue. And so it wasn't actually able to collect 30% of its data. So, engineers and scientists had to figure out how to correct this and how to deal with this problem. So when we're doing science measurements, things like this happen. And we have to figure out how to make use of the other 60% of the data that this particular satellite was able to collect. We were able to overcome that. And we were able to make use of all of that other data, primarily because people documented what happened, their processes, as well as we worked as a community to figure out the best things that we can do with satellite data or with this particular data set. So, when we think about the GLOBE database, we can think about, similar challenges. Maybe there has been instrumentation changes over the years. GPS has gotten better. I know I can locate myself better. And there might be other database errors that might be in there. New protocols might have come online. And so, this is an important part of our science process, especially as we look back in time. We reveal problems with maybe our approaches, maybe who was involved in the program at a particular time. We know that the GLOBE program has brought new countries on board at different points in time. So their data is going to be different. The depth of data, the timeline of data is going to be different. So these are all interesting challenges as we think about documenting climate change, a changing climate. And how do we do that in a way that is equitable, where we are comparing the similar sort of measurements across the global community? So again, I go back that this is one of the wonderful things that I see with the GLOBE program, is that we can actually start putting together multiple data sets, right? And that's what we've been doing here. And so here I'm just highlighting the land cover photos, but if you actually zoom in, I did a tree height at one of these locations. And so what I really appreciate about the GLOBE database is that if you do this right for a location, a pixel, you will have atmosphere, biosphere, hydrosphere, and pedosphere all described in that location. And if you don't have that information, that's really when we have to turn to somebody else who made those measurements. And that is where we end up going to places like maps or products that scientists have made. And I want to highlight this one because this particular data set that we're going to focus on this year is a global data set. That's important for us. Equitable, so everybody's working with the same data set regardless of the country you're in. So we can actually do a comparison. And what's neat about this particular data set is it is using the laser data we've been talking about from the GEDI, the Global Ecosystems Dynamic Instrument, as well as ISAT-2. It uses that structural measurements, but because we don't have those globally, we had to use Landsat data that gives us those global measurements. And scientists combined those two together to come up with this global forest height canopy height model. Okay. And so there is this data where we can go in and we can actually explore for every 30-meter pixel, what is the height for a particular location. So we're going to dive into some more specifics around this, but I want to just show you what we can start seeing with something like this, because again, this is the kind of data that is just becoming available to us. And so we want to help you understand it and make use of it. One of the other important data sets that we've highlighted in the past, but we're really going to drill in, again, equitable. We need a global map when we're talking to each other. And so there's scientists in the European Union who've used some of their satellite data, and they've put together this land cover map. And it has all kinds of really interesting data, especially around forest and trees. So again, we'll dive into this pretty deeply. And then I want to highlight a new citizen science project that actually is doing globe data, data collection. And so you'll start hearing about this because this is perfect for this changing time of the year. And as we think about elevational gradients, is it rain or is it snow? This is a really important question as we go into climate monitoring changing climate. We know that there's going to be some areas that currently are snow regions that are going to start getting more rain. And so we as a community can actually help document that when you use the Globe Observer. When you do those surface measurements right at the very beginning, you're asked, is it raining or snowing? And if you actually help us to denote that and at what elevation, that actually really does relate to the potential for those trees to grow to the tallest height that they're capable of, right? So even though we're focusing on trees, there is this atmosphere piece that rain and snow and that precipitation really help to close that water cycle and the carbon cycle. So I've taken up quite a bit of my time today, but I wanted to give you guys a sense for where we as a team want to go this next year. And we want to help dive into these particular data sets with the Globe data and with this new exciting Landsat 9 data that will be coming online in January this year. And we're going to be one of the first groups that start looking at it. So come back in November, learn a little bit more about the methods and these particular data sets. And what is going to be presented today is a great primer and a great way for you to start thinking about all of these pieces that we presented over the last 3 years. So I appreciate you guys coming today and everybody else who watches this after the fact. We're really excited about looking back at 50 years of change across the globe and seeing what kind of information and things we can reveal from these patterns. Thanks.
Yeah, this is so exciting, Peter. Thank you. I'm so excited about looking at the past 50 years because, as you know, everyone knows at NASA and lots of science agencies and institutions that they one of the most important things is to look at change over time. And that's one of the main things with this campaign as well, because we're in year 4. Hopefully we have a year 5, and 5 years of looking at change over time is kind of that gold standard. I know that NASA does when it looks at at specific change. So 5 years is kind of that awesome starting point for looking at change over time. But now we're talking 50 years, so great stuff. So let me pop back to my presentation, and then we will get started with the featured presentation. So today, we have the honor of welcoming Yashraj Patil from Globe India and a GISN member. He will be talking about his Himalayan expedition and looking at the Globe program's first high altitude Globe land cover, cloud, and hydrosphere data that he took during this. And he will be sharing all this great information with you. I was able to see Dorian and I and Peter, both Peters have been working with Yashraj for a little while, discussing, the best things to do, with the expedition and everything. So this is great. Don't want to steal his thunder because he's done above and beyond what we were thinking he was going to do. So this is amazing what you're going to see here. So I had the honor of watching his presentation that was led by Desh Bandhu, who is, on this webinar. And this was the Asia Pacific Regional webinar, and it was on our time here. I was part of it from 1 a.m. to 3 a.m. in the morning. So, but it was so worth it. So needless to say, I went right back to bed after it, but it was great, great to see this. So I'm excited for this, and he's modified this a little bit for for basically our time constraints and our focus with the campaign. So I did put the link to the story map here, but I will also put it in the chat if that's okay, Yashraj, if I can do that. But I'm going to stop sharing and I'm going to introduce Yashraj Patil and let him go from here.
Yeah, thank you. Thank you, Brian, for this wonderful opportunity. I'm so grateful to be here presenting the Himalayan expedition. Let me know if my screen is visible.
Yes, looks good.
Okay, that's great. So basically in the month of July, from 27th of July to 2nd of August, for 1 week, we were into the Ladakh region for the Earth and Space Exploration program that was focused on the some aspects of the Himalayas that are actually changing with response to the climate change. So this was specifically organized by the MIT University Mumbai along with Blue Marble Space. After that, Mars Society Australia, European Space Agency, and also some departments from NASA. So many of the scientists were not able to come, mostly the international scientists due to the restrictions of pandemic. So they guided us throughout the online sessions, and we conducted those experiments along with implementing the most lovable program, which is the GLOBE program, of course. So all of you know about I'm a GISN member at the GLOBE program, but along with that, professionally, I'm an associate software engineer at the R&D section of the IMS automation department at the Hexaway Technologies. So I'm so interested to be in the science field also alongside with the technological field also. So I'm just trying to collaborate with these two fields using my skill sets. And I have recently completed, last year, I completed my Bachelor of Engineering in Information Technology from the Pune University. So moving towards the agenda of today's session, so we will be looking to the formation of Himalaya expedition site, and yes, the expedition sites I will be explaining using the NASA Landsat Imagery. So thanks to Doreen, Brian, and Michael Taylor, who actually in the short time of period, I was just touching down at the Ladakh. They shared those Landsat imagery using the coordinates that I shared of expedition sites. So I will be introducing you through that imagery. Then we will be looking towards the GLOBE protocol that I implemented in the high altitude region, and what I face specifically, the challenges I faced as I was, as Brian added about the same thing of the trees measurement, but what actually went wrong while studying those geology and geographical factors that I need to convert, I need to change those GLOBE protocol on that spot. As I plan, I need to change, make changes into those plans. Then we will be looking into the GLOBE visualization system tool, just like now Peter Nilsson just introduced you some snaps of that thing. Then we'll be also looking in the NASA Langley Research Center's cloud cover report that obviously you get after your data gets matched with one of the satellites from the NASA Earth observation satellites. And then I'll be introducing you to the some sorts of GLOBE protocol suite selection. So how could you customize your GLOBE protocol according to your visit to any kind of region you are willing to have those observations, study those observations in the perspective of the GLOBE program, also in the geological manner and the geographical manner. And then I'll be introducing you towards the research methodology that I went through. So first of all, I would like to ask you to scan this QR code for what do you love about Himalayas, or what do you know about Himalayas, so that I could get things like how could I explain those aspects of Himalayas in a better way. So we will have some 1.5 minute timeline for this particular slide, so that your answers will be popping up into this slide, into this active poll. So you may head on to the slido.com and use the mentioned passcode and Just write down what you love about Himalayas.
And I put the link there that everyone can, just click on that link in the chat and that'll take you to it. And then there's a spot there to enter the 187411.
Okay, so we are getting the responses. Okay. Yeah, exactly. The land cover is changing drastically. Like from region to region, you will be getting to see different kinds of tree, not the trees formation. It will be in the low-lying areas in the Himachal Pradesh or the Uttarakhand states or the Jammu and Kashmir state. But in Ladakh, it's totally cold desert. So you will be seeing those land cover variation in the form of typical desert forms. Yeah, so we have received many kinds of different aspects of the Himalayas that you are aware of. So I will be introducing you towards the next slide, like uh, what actually Himalayan formation took place. Before that, I would like to share my some snaps that I took from while traveling to Leh. So as you can see over here, you may concentrate on my cursor. Just like for adjusting the turbulence, our flight was a pilot was at in between the troposphere. So I just got this different view of the troposphere beneath this cloud. You can see this Himalayan ranges above cloud. You can see this. This is the troposphere spheric edge that is being used to tackle up for the turbulence. And you could see this cloud formation and the blue sky, clear sky, mostly because this total region is not so much polluted compared to the southern part of the Indian subcontinent. So okay, so you see this fluffy and some like it's kind of the cotton balls floating in the sky. So it was totally a different and incredible view from the airplane. And I must suggest you that you must head on to Ladakh from Delhi to Leh. Actually, this path gives you different kinds of line cover forms. So right from Uttarakhand, you could see those greenish and the trees formation. Then instantly the land cover changes and landform changes, and you could see white snowy Himalayas starting to get up below. And yes, also I just studied this climate change kind of factor, that you could see this formation of fresh glacier over here. And this one is little bit older, but you could see this is in the dull white color, and you could see this fresh white color. So this might be the reason of some kind of sulfur and nitrogen elements that are reacting to this snow glacier and the ice caps that actually is being affected due to this climate change. And of course, the pollution in the New Delhi area is now heading up to the northern part of the India. So this is a kind of concern of the pollution that we are being drastically affecting the Himalayan region. You can see the snow changes, the shades of the colors over here. And now moving towards the actual formation history. Before that, I would like to know about that ocean that got erupted during the collision of the Indian plate and the Eurasian plate. So I will say, like, you must rank the first rank will be your most accurate answer or your most accurate guess, and the fourth ranking will be your least accurate guess. So you may again visit to the active poll, and you may rank it in your guess manner. I must add the first one will be your most accurate or the closest guess to this ocean, and the fourth will be your least guess. Okay. So looking at the pool. Yeah. So it's right. The Tethys Ocean was the ocean that got disappeared during the collision of the Indian plate and the Eurasian plate. Over here, you can see just during that Mesozoic period, the continents started to separate from each other, and you could see this new Tethys Ocean, or the Tethys Ocean that used to be present during that era. And this Indian plate is moving from upward towards the Eurasian plate, and this is how the formation of Himalaya took place. There is some small video that I would like to play. I'm not sure. Okay, so you can see in this video about how the continents started getting separated from each other, and this whole area was the Tethys Ocean. And this is the Indian subcontinental plate, or the Indian plate, and the above one is the Eurasian plate. So that seabed literally got abrupted up in the upper force due to those high pressure of the collision, and it totally, the Tethys Ocean totally disappeared. And what we see now is the remains of Tethys Ocean is the Arabian Sea, Bay of Bengal, and the Indian Ocean in the southern part. So this is how the formation of Himalaya took place. Now coming towards the Himalayan expedition sites, we were having 4 different expedition sites. The Saboo village, which is responsible for the cloudburst, then Tso Kar Ramsar Site, which is the salt high altitude closed basin lake system, the Indus-Yarlung Suture Zone. This suture zone is what I'm saying. This is the where beneath that suture zone is the active tectonic line that actually separates the Indian plate and the Eurasian plate. So this is much more interesting manner in the geological aspect. And the Puga Geothermal System, which is having a kind of similar geyser to what the Yellowstone have, but compared to those pressure and the heights of the steam getting up in the upper manner, this Puga Geothermal System just expels out the water and the steam up to 1 to 2 meter high. So I will be moving towards the expedition sites. Okay. So yeah, so as you can see, this is the Saboo Cloudburst Site in the story map, where this total actual cloudburst happened during the August 2010, and at that time it clicked about the some kind of wrong things happening in the Himalayan region. So everyone started focusing on those things, because in the atmospheric manner, or in the as per the Indian monsoon system, the Ladakh region is the rain shadow region. So Ladakh never receives such kind of heavy rainfall. But since 2010 up to till now, like even when we were visiting, we were also looking towards those thunderstorm that was reaching to this rain shadow region. So this is a kind of concerning thing. So I just head on to the world view from the NASA service, and I just gone back to the August 7 and August 8 to compare what actually how the cloud formation was there over them. So at August 8, the cloudburst happened at this site. But as you can see, the 7th of August image and the 8th of August image. So this literally gives us some sort of idea that we couldn't actually have those predictions over the cloudburst. But as you can see, the monsoon clouds are actually covering this whole Ladakh territory. So this is kind of concern, because being rain shadow region, it never receives the rainfall over there. And this is the sand ramp that actually is being result of the glacial and the wind activity in this cold desert region. And main focus was to yes, this one. As we were standing over the this Eurasian plate, the picture where I have taken is in the geological manner. We are in the foreign land. That is a kind of fascinating thing, because this place was the actually Eurasian plate. But as you can see, these are the Tibetan Himalayas or the Zanskar Himalayas that are in the Indian plate. So the Indus River separates those two different plates, the Indian plate and the Eurasian plate. And this is the Stoke village. So you could see some sorts of formation, trees formation, or some sort of greenery in specific local regions or the specific residential regions for their livelihood purpose. And these are the lay berries. I must add, these are only found at the high altitude cold desert region. And the most interesting fact is that it contains a large amount of vitamin C that is said to be 12 times higher than an orange. So basically at such high altitude region, we obviously have less amount of oxygens, and for that purpose the nature is incredible in its true self, providing these kinds of vegetations in that perspective manner. And this is the video of the Saboo Cloudburst Site. Okay. Okay. I think there is some technical issues. It's okay. Okay. You may visit this story map and view this video. The main focus I took this 360-degree view of the Saboo Cloudburst site was. Please let me know, am I audible? Because am I audible, Brian? Hello.
Yes.
Okay. I thought a kind of latency issue. So, okay. So basically, I took this video because of you could see the water or the glacial stream at the another end, the trees on the other side, and the sand dunes and the sand ramps on the its opposite side. Those monsoon clouds now actually due to change in monsoon system of the Indian monsoon system, you could see these all things together in the single place. And being as a cold desert, it is nothing like that now, because now it's totally changed. So this is how I took that image. Now I would like to head on towards the Indus-Yarlung Suture Zone. So this is the suture zone that I was talking about. So at this in the left side of the screen, which is the southern side of the which is this southern direction, and this is the northern direction. So this is the this part is the actual Indian plate, and this is the Eurasian plate. So Indian plate has typical sedimentary rock formation formed under the Tethys Ocean, while this Eurasian plate is having also called as the Ladakh batholith, and it is composed of granite and igneous rock formation. So this rock formation varies due to continental plate variation, and this suture zone is actually dividing those two continental plate, and below that there is active tectonic line that passes through this zone. Okay. And yeah, as I was saying about the Indus River, so this is the Indus River, and as soon as you step in the front manner, you land up into the Indian plate or the Tibetan Himalayas region. So this was a stunning view of all aspects of the nature. And this is the carving of the nomads, what we believe. This is the nomad, and this is the Himalayan blue sheep. So we also found the nomad carvings near the river bank of the Indus River. Yeah. And now coming towards the seabed kind of thing, as I said, like the Tethys Ocean seabed got abruptly erupted. So you could see this whole formation of the rock formation and the seabed kind of structure. As soon as you pass through these all Ghat regions and the valleys, you could experience some sort of kind of illusion or something like you're in beneath the ocean, and you're passing through the ocean, as you see in different kinds of cartoons and the animations, where the unimaginable things are being portrayed over there. So we just stopped here. This was not actual the expedition site, but we just got stopped by for the random sample collections of the lichen, so that we could find the extremophiles, either the tardigrade or the rotifer. So luckily we found the rotifer, and it was the first discovery that in the Himalayan region there are extremophiles that can sustain obviously into the high pressure, high UV radiation, lower oxygen, all those extreme environments. Yeah, this whole formation of the rock and the mountains totally changes region by region. Next, in the next few kilometers, you could see this plain steeping kind of formation, and next few kilometers after that, you could see these kinds of structures. So this is how we could assume, or we could analyze those things, like how it would have been impacted during the collision, and how that seabed formed in the form of Himalayas over there. And this is the Tanglangla high motorable pass, as you can see, which is around 5,320 meters high. And I took line cover observation, and this is one of the picture from the line cover observation. The thing I took line cover is because I couldn't find any trees logically over here, and I could only see those ice caps being at the top of the world into the second highest mountain pass, and those some sort of glacial deposits also over here. So I took these kinds of landforms so that we could get some kind of scenario, like how the top of the like how this topography changes at the highest altitude, at a high altitude region, in between 4,500 meters above above sea level, or to the 7,000 also. Yeah, so that was the all about the Indus-Yarlung Suture Zone and the Tanglangla. So this is the Landsat imagery that I was mentioning about. Yeah, so you could see these high Himalayan ranges varying in between, and those ice deposits or the glacial deposits over here, the snow deposits. And this is the Pangong Lake. This part is in the Indian side, while half of the lake is in the China side. So this is much more spectacular view, and the water over here is so clean and so transparent. So it signifies that cleanliness and the water transparency over here. But this was not the part of our expedition site due to the border issues. So this is the Tso Kar Ramsar Site. Over here you could see this. This is the hypersaline lake, while this is the freshwater lake. And the thing that amazed us is it is being connected through some sort of small streams of water, and they never get mixed up with each other. This is some sort of mysterious, still a mystery over here, that we couldn't find the thing of the Tso Kar. And I took some kind of line cover, also the hydrospheric observation of over here, as I couldn't find any trees in the Tso Kar. And moving towards introducing the actual importance of the Tso Kar is, like, today it is a wetland, a marshy kind of ground surface. You could see over here the brine pools, the paleo lake sediments, and there are some moss mounds which tells us of the permafrost built topography in the region. You could see this paleo shoreline. So in the ancient time, the water level might be, it signifies the thing, like in the ancient time, the water level might be 90 meters high, over here, the water was there, but soon it got it decreased in that manner. These are the moss mounds over here, and these are the rat holes. So we do find the Himalayan rats over here hopping into these moss mounds, and this signifies that this whole lake system is the permafrost built topography. So beneath that is the permafrost that is so hard to dig over here, because this land cover is totally much more stronger over there. And we found this animal is called as a kang, or the Tibetan wild ass, which is the hybrid version of the donkey and the horse. So they basically graze in this Ramsar site, and these are the endangered species. So so the Ramsar site is being added, and the importance is being added to this to protect those species. And also we didn't encounter with the snow leopards, but the snow leopards were actually coming in the night time. So we didn't got to see on this. And this is the panoramic view of the Tso Kar region. So you could see. And one more thing I would like to add is the this whole thing is such kind of illusion. Even it is kind of closer to what we are looking at, these paleo shorelines, but these are actually 5 to 6 kilometer or the 10-kilometer far away from the point where this photo is taken. So these kinds of thing, the reason behind this is the clear atmosphere and clear visibility, and this signifies that there is lesser pollution in this remote site. So now the pollution which is being collected above the New Delhi and the North Indian states is heading towards this region, drastically changing all this topography. So this is the concern right now for the Himalayan region. And you could see this is the freshwater lake, or the Star Sopak lake, and on the other side this is the whole Tso Kar lake. So this water is totally dependent on the glacial and the snow deposits that actually melts during summer, and gives this ecosystem a different kinds of perspective. And this whole greenish, or this whole grassland is actually being formed over the salty lake region. So this is much more interesting thing that we came across. Now moving towards our final hot spring site, which is the Puga hot spring. And Puga hot spring, actually the geothermal system, it is near to the Tso Kar region, so it was actually accessible by the road. So the main reason for the Puga, visiting the Puga, is because of its diverse biodiversity and the vegetation. As you can see over here, this is actually the geyser or the Puga hot springs that actually emits the sulfur contents, and in the majority purpose it emits it deposits the boron. So we found the boron deposits in over here. This is called as a hydrothermal deposit or the sinter deposits, and the reason behind collecting this is to study the extremophiles. Although we found some extremophiles in the lichen that we collected in while traveling to this remote site, there is a shrimp that you could view in the story map that we found in the Tso Kar lake. So now we are heading to see whether these sinter deposits or these hydrothermal deposits contain any kind of extremophiles that actually sustain to this high temperature. The temperature of this water was around 75 degrees Celsius. So due to the cold desert region and the cold temperature, we could sustain up to 1 minute. After that, we could feel that extreme heat, and literally we took out all barefoot and the barefooted leg outside of this pool. This entire landscape is actually the Glacial Valley. So you could see this in the summer, but when you view this thing in the winter, or the right from October, November, starting from October, November, you could see a whole thing in the covered by the snow. So that was and this is the diverse diverse vegetation that is being formed due to the warmth of this geothermal system. So and the thing is, this here also we identified those moss mounds, and while reaching towards the geothermal system or the actual geyser, you need to hop on to those moss mounds, and while doing so we found these different kinds of vegetation or the some sorts of plants or the grasslands that are actually what we saw in the starting of the presentation was the coniferous structure of the Himalayan aspectus, in the way that the snow never settles down over the trees, and it the tree slips away from the leaves. So over here it is totally opposite. So this made us surprised, being the ecosystem in the actual Himalayan region. And this is the sinter deposit. As I said, it mostly contains majority of boron along with some sulfur and other kinds of elements. And this is the scenic view over here. So this was actually all about the expedition sites that I visited during the Himalayan expedition over here. And these are the coordinates that I from the Landsat imagery. And I'm so excited for the Landsat 9 imagery to compare the Landsat 8 imagery with the Landsat 9 imagery with the same coordinates. So you could see all those Himalayan nerves, what we call in our actual casual manner. These are actually the top of the mountains, heights and valleys over here, you can see. So this was all about the Himalayan expedition sites, as I mentioned. Now moving towards the globe protocol Himalayan suite. So while visiting the region, I was planning a whole thing in the another manner. So in the another manner, I mean, like I was knowing like there is no internet connection. The power is, we are also having at the remote side there was no power. So that was a challenge for us. So I just took out all the printouts for the 7 days, like for 1 week. Of the atmosphere, biosphere, pedosphere, hydrosphere, all those globe protocol I took printout. And while I was confirming like what kind of thing I need to carry on, because the weight also was actually being matter during the back checking. So so for that purpose I was some sort of conscious about the thing that I need to focus first on. So as I was being suggested by Brian, Dorian and other globe members, that you must focus on the land cover. So land cover is the first thing that that is must to be taken. Then afterwards Brian suggested about the trees observation. So as soon as I step into the remote site, I didn't find any kind of trees as you saw in the previous pictures. So I need to cancel that trees observation plan, and I had to just depend on the land cover. So I just and the cloud cover. So during that phase, the Indian monsoon system was in the active manner and it was heading towards the rain shadow region. So I selected the cloud cover and the precipitation over there, and the air temperature also. While the water pH and the salinity was actual according to the plan, and I got those observation over there. The pH was actually in the hypersaline format, what I was actually assumed to be, and the salinity also of both the Tso Kar and the fresh. In the fresh water, I found the neutral readings, while in the Tso Kar, I found it in the form of saline and brine manner. And the NASA Earth observation satellite. So this was the much more kind of challenging thing for me, just because I was not having any kind of internet over there. So I need to track those Earth observation satellites. So since last year, I joined GLOBE program. I was actually tracking the NASA's Aqua and the Terra satellite overpassing, like when they are overpassing over the India. And I found that the Terra passes during the in the morning, during 11 a.m. into 12:30 p.m. So during that phase, it overpasses through India, and the Aqua passes in the afternoon during 1 p.m. to 2:30 p.m. So that was a kind of my average readings of the overpassing timing. So I just collected those data during for the cloud cover purpose, so that I could match those data with the satellite data, and I could get that specialized report from the NASA Langley Research Center. So I must suggest I must add this was all about the GLOBE protocol Himalayan suite that I actually designed, and that actually got changed while I was into the site. So what you predict or what you assume and what actually happens in the reality is totally differs from each other. So you must be conscious about those things, and there must be a plan B ready for that. So now moving towards the selecting the NASA Globe protocol suite. So I must add that first of all, you must know your scientist trait. Actually, this is out of the thing of the what the observation is being taken, but as if you're curious or courageous, you don't need to be all in all this trait, but if you're curious, courageous, that give you some kind of confidence on the kind of boost that you need to identify those things. You need to study that region. So if you identify your own scientist trait, then definitely you will be more creative, and you could find many more things that the normal person couldn't find out. So this is what I'm suggesting for you. Before, while selecting the protocol, so you must identify your scientist trait, where you are specialized, where your interest is being specialized. After that, you must understand the region history and the geography. So as you are heading towards that any kind of regional observation, you must know what kind of region over there is. As Peter Nelson focused on those landform variations during his presentation. That region actually varies. I saw that it actually varies from such a short distance. In the short manner, it got varied from snow to a whole sort of green vegetation. So we must identify those region, and this is much more important by selecting the globe protocol suite, and also the geological aspect along with some geographical factors. So combining all those things, you will be able to identify the perfect globe protocol for that particular region. And also always try to keep the track of the NASA's Earth observation satellites, or the polar satellites, especially the Terra and the Aqua, because the internet never guarantees its availability in everywhere. So if you are visiting mostly into the remote region, prior to your visit, just have those average timing schedules tracked with you, and before 1 month, I must say. So that will help you to get all those data, because what my satellite got matched was the 2 to 3 observations. So that was actually much more than I expected. I was expecting just a single one, but it got matched with 2 to 3 observations. And also try to work with local partners. As with our expedition, we were having the students from the Ladakh Science Foundation. So they were very well known with the topography, and they were actually explaining in a better manner. So you could get more inputs from the local people. So try to work those things and prioritize your field work. So prioritizing the field work in the sense is, you must prioritize which protocol first you need to implement. So if you are at the higher altitude or at the higher heights, you must first prefer the landform, because from the more advanced heights, you could get a proper data collection of the landforms compared to the lower heights. So in this way, you must prioritize your field work. And those are the research methodologies. So once again. Okay. Yeah, I'm sorry for the trouble. So there must be some sort of the research procedure. So you must identify, as I previously added, there is region significance, then choose your study spot. It is much more important. So choosing your study spot gets confirm your coordinates. So you must note down your coordinates, the elevation, and collect those data. So during that phase, thanks to this amazing creativity of the Globe program, that they are offering the offline data collection also. So it made me easier to collect those cloud data in the offline manner, and I could record those coordinates simultaneously. Also, the paper-based observations were there of the hydrospheric data. So all those things, and also the sensor based. So if you are carrying out any kind of sensor or a temperature sensor or different soil sensors or the water sensors, that must be also in the form of that must be collected in your research or in your observation for the accuracy purpose. Then you need to analyze those data prior to the satellite matching report or any kind of different data that you get from the external publications or research papers. So you must analyze those things and prepare a study report or the story map. So as I was confused, like how should I proceed with all those stuff that I collected from the Himalayan expedition. So Dorian Bryan helped me to make it in the form of the story map. So it was my first time to design a story map. Before that, I never designed a story map, and I learned many more things during those periods. So story map is the best thing for you to be actually available 24/7, that access. So, and moving towards the kind of data, so your primary data must be the observational data, the local interview or the discussions with the locals. What you must note down those things, or you must record if they are not having any kind of issue recording, and the sensor based data, while your secondary data must be the research paper or regional record. So before visiting Ladakh, I studied whole topography, the geological, geopolitical, and the geographical aspects of the Ladakh region, so that I could get more clear picture and understand better way, and in the less time I could grasp more things. So that was the aim behind the preliminary preparation for the expedition. And while conclusion, you must use the DEC formula, like the DEC formula. I just use it in my personal manner. You may change according to your own easiness. The reason behind this thing I selected is the DEC, in the sense the short form of the December, which is the end of the year, and the conclusion is always added at the end of the report. So I just abbreviated in that relative manner, which is actually in the full form. It's actually the descriptive collection, experimental collection, the comparative experimental conclusion, and the comparative conclusion. So in this way you must prepare whole research methodology according to the visit of your local or some other regions. So I must move on towards the space-based data analysis. So as you can see, I got my data got matched with the Terra satellite, and during that phase, I could see those difference, like what satellite actually fails, what actually hinders during their observation. So you must see those things. You could see the high cloud cover is not visible from my side, but it was visible from the space. The same for the mid. But for the low cloud cover, which is actually the rain clouds, they were not visible from the space, but I actually submitted those data. So that actually made kind of more accuracy and more analysis in a fruitful manner, that actually helped the Langley scientists also, and for me also, to study that geography and the region. But the thing is, at that time, the trajectory of the Terra satellite from north to south pole was away from the northern Indian state. So please don't refer it as a Pangong lake. It is the lake in the Afghanistan. Over here, the rapid response imagery, this is the Ladakh, Jammu and Kashmir region. But thankfully, I was not hoping this kind of accurate cloud matching report, but it got matched. Fortunately, I was much lucky to be over here, and I never felt that much guilty, like I failed to track the Aqua satellite, because one satellite in the offline manner, what I took the hard efforts to track those satellite, and it actually proved in the form of the timings, timeline and the timing schedules of those overpassing, actually proved that you could track those satellite in the offline manner, and you could collect that data during that particular overpassing time, which apparently the satellite passes over you. And this was that period of the world view that I got access. And this is the geo satellite. Obviously the geo is it never it's still in its orbit, so it got matched anytime whenever you share, or whenever you upload that cloud data over here. So now moving towards the globe visualization system, as you can see over here, the data is not being shared right from 1995 of this Himalayan region. So it was the first high altitude land cover and the hydrospheric and the cloud cover that I got to know about those things. So I took different data from the different locations. This was actually the age that is being dried up. This region is being dried up, as you can see, of the Tso Kar, and while this remains some sort of bottom. So I took those things over here. And moving towards Puga, as you can see, this greenish vegetation, it's actually been mapped into this OpenStreetMap of the globe visualization system. So these are the land cover observations, because these species are very much rare, and they are surprising in the form of, over the small region only you could find this vegetation in this huge cold desert. So it got me much more boosted in the form of a boosting manner. Like, I must record this thing, I must record this line cover. It is much more necessary for this. And for the first time I got to know, like, this line cover is being measured over here. And over here you can see the data count. So in the data count you could see when whether any kind of data is being observed before the data collection of your own date. So I could see it for the first time this data is being submitted to the globe program. So it is much more exciting. So that's all about the all the Himalayan expedition presentation and all the globe protocol. So if you have any kind of doubt and questions, you may contact me later on about those Himalayan expedition, or the story map is available in the detailed manner. And this is the twilight magic at the edge of troposphere, as we were having our ATC holding while approaching towards Mumbai. So it was a kind of twilight time, and I just while our flight was circling around, so I just went through this amazing view of the sunset in the troposphere. So that was, and this was my first air travel. So I was much more excited to see what clouds look from the top of from the troposphere, or the beyond the troposphere. And these are the Mumbai night lights, same as to what it is much more interesting that I'm so excited to see the New York's night lights from the sky in the future. And finally ending my journey. So I'm open to the Q&A. That's all.
Hi, Yashraj. This is Peter Falcon from the Trees team. We have quite a few questions for you in the comment
Yes,
box, and lots of comments about how wonderful your photos are. I mean, wonderful, amazing, majestic. You really need to, when you have time, please look through the comments to just see what people are saying about your photos and your research. But there are a couple questions I wanted to ask you that people
yes.
asked here. So let me go ahead and scroll up and start from the top here. Give me one moment. Where was I? Okay. So our own Brian Campbell asked a question, and he wanted to know, what are some of the major obstacles you encountered on your travels and in your research?
Okay, so first obstacle was the temperature variation. So actually in the summer, the Ladakh's temperature varies from 0 degrees Celsius to 5 degrees Celsius. But due to the monsoon system, the introducing of those clouds from this southern part of the India, that temperature drastically changes to the negative manner. So it was much more challenging for us to have sustain in those temperatures, although we were much more warmed and double coated, triple coated using our sweaters and the jackets. But that was a thing that caused a kind of obstacle during the observation. The second is the lack of oxygen. So Lack of oxygen in the sense is the high altitude region possess the less amount of oxygen, so it was much more kind of thing for us, like we need to preserve our energy because we need to keep our body warm. At the same time, we need to uh, record our observations, and the thing is expedition program was the projects were in the different form, and my own research was in the different form. So at the same time, I was handling these two balances, and I need to preserve those energy for that purpose. So the oxygen thing was the second obstacle. Third obstacle was the huge wind gust that actually carried huge sandstorms, which actually blocked our vision far from away. So we were waiting for a particular period because the weather over there actually changes from 15 to 20 minutes. As you see in the story map in the Puga Geothermal System, at the starting of Puga Geothermal System, you could see there are huge fogs present over there. And right after 10 to 15 minutes, it actually changes into clear, bright sky. So we were actually waiting for that particular point where we could get a clear picture, clear observation to record our data collection. So that was the three major obstacles. And yes, the trees we didn't found in those cold desert regions. So I need to change that thing actually at the same spot. So you need to have your plan B ready with you if such thing happens.
Understood. Yes, Anna made a comment about the photo that you took of a sandstorm. She mentioned like, "Ooh, sandstorm." That looked interesting. Speaking about the oxygen, what elevations were you? I believe Emmanuel mentioned you were around 11,000 feet or so.
Okay.
And did it change from place to place?
Yes, indeed it changed. At the day one, we were where the Leh city or the district is, where we were staying. It was around 3,500 meters above sea level, and actually, while we were going from to the our remote site, it actually varied from 4,500 to 5,500 meters above sea level. So during that phase of those elevation, we were actually for the at that higher altitude, right, from 4,500 meters above sea level to the 5,500 meters above sea level. So that was the longest exposure to these greater heights.
Wow. And did you need to take oxygen from time to time?
No, the thing is, my colleagues, I was actually okay with the oxygen I was having, but as soon as you get anxious or some sort of any kind of thing, like you are remembering your mother, father, there is no contact. I mean, nothing. For 4 days, we were out of network. So at the last day, I was having some sort of anxiety. So during that phase, I needed oxygen for some particular 15 minutes, but despite from those anxiety, I never received the oxygen. But so those high altitude sickness varies from person to person. So many of those who were having such issue actually needed oxygen from time to time. And you never know like how your blood pressure actually varies from drastical amount. Like many of the thing, like one of my colleague who came up to those high altitude, who sustained for some few hours over there without being having any kind of sickness, he started having some sort of headache over there. The headache is actually in the normal manner because of the lesser oxygen towards your brain. But we were measuring his oxygen pulses, so that was around 90-95. It was actually great to see he's having a greater oxygen, but still he was not feeling well. So as soon as our team carried him back to Leh in the evening, we found there that he was having some sort of low blood pressure. So that was the reason for his headache, as the blood could reach at that moment. So those things actually matter. Your health, you must keep a track on your health, and acclimatizing is the much more important factor at the high altitude region. So if you change your altitude from 1,000 to 2,000, 3,000, 4,000 in the single day, you must rest for 24 hours at least.
Wow, very interesting. Never, did not realize that about high altitude measurements
Yeah.
there. Another question we have, this is from
Hmm.
Marcus. He wants to know, how did you travel from one site to another during your
Okay.
expedition? And what was the region populated? How was the region populated and who lives there?
Okay. So the team was having their own vehicles from the Ladakh, coming from the Ladakh region. So they were booked for the traveling purpose. So because we couldn't travel much more than 1 kilometer, that is never being suggested for for some such short period of acclimatization. So we were being carried out from the traveler or jeep from one place to another place, and the population over there was in the manner of few, like from 25 to 30 people in those remote site, and they were majorly gathered over there for the summer region, summer purpose, during the summer timeline, because during summer the whole snow gets melted over there, and there is a kind of new vegetation for their own shepherds and sheep and all those grazing purpose, and they move back to Leh or to the town during winter, like from October to November. So population was much more on the in the counting manner between 30 to 35, like that.
Gotcha. Okay, two more questions. Uh,
Yeah.
were you surprised to not see trees at that elevation? Did that surprise you when you got there?
Mhm. Yes, yes. I mean, I was about to see those trees in the Leh region, in the city region, but the thing we were being carried out on the day one, right from we never being suggested to walk as soon as we landed up. So we just travel directly to our resort, and we just had our lunch and directly rested over there. So during that phase, I saw some trees in the city that have been planted by the Indian Army and the local communities. But in the remote sites, I was surprised to see that there are no any kind of trees, and that was the thing I got shocked at the first moment as I saw in the Tso Kar and Puga geothermal system.
Gotcha. And our last question is by Peter Nelson, and he asks, have you did any quality check of the locations and data that you submitted to the Globe database? And he asks, when working offline, do you have a map in Globe Observer mobile app to confirm your site locations?
Oh,
Yeah,
yes, yes. Can I ask again for the first question about
of course,
the?
yes. Have you been able to quality check the locations of the data you submitted to the Globe database?
Yes, yes. We were having the GPS meter, the remote GPS meter with our team. So their coordinates and the coordinates using my iPhone actually matched nearby. So the Globe Observer app was actually the accurate to use the system's coordinates mapping those things during that phase. So
Gotcha.
they were
And
accurate. Nearly.
gotcha. Okay. Uh, and then you just mentioned, when working offline, you don't have access to the Globe Observer map or mobile app. So
Mhm.
you just mentioned that it's important to make sure you do these types of steps to confirm the photos and data when we archive them.
Yes,
So
yes.
you just wanted to make sure that we did that. Excellent. Okay, well, thank you very much. You did a wonderful presentation. We have lots of comments, so please feel free to look through them. So with that, I think I'm going to go ahead and turn it back over to Brian for our next presentation.
All right,
Yeah,
thank you,
sure.
Peter, and thank you so much, Yashraj, for that amazing
Yeah,
presentation. And I,
thank you.
I have on the chat here, posted it several times. Everyone, please take a look, closely at his story map, so you can see, the methods that he used and the protocols and why he did these protocols in these different regions, and the things he saw. So it's super important to do that, so that you can, bring back to your students or even, other citizen scientists about, how to do this research in your local environment. As I mentioned, it won't be probably as grandiose as going to the Himalayas and going to all these different zones like Yashraj did. But I think it's important because the methods that he used to do this, and one of the methods that he just talked about and that Peter Nelson asked about, with the connection and making sure that the, you know, the GPS location of your observations is correct. Yashraj did that. He confirmed it. You know, the key, as Peter mentioned here in the comments, the key is that there was confirmation with another GPS device. So it wasn't just relying on one single thing. It wasn't just relying on your phone when you're taking the observations, but that it was confirmed with another device. And you know, so this type of research that Yashraj did is really great catalyst to getting, you know, students, you know, started with, you know, just taking, you know, observations using the GLOBE protocols in their local environment. So thank you so much for that, Yashraj. And right now, with the time remaining, we don't have a lot of time, but we're good because, as you know, we always have so much to talk about during these webinars. I'm going to pass it over to Dorian, and she is going to introduce you to the Lifelong Learners Program and basically talk you through, you know, what she has been doing with this. And it's one thing that we want to also focus on in year 4 of the campaign, to get the lifelong learner community working, you know, with folks, the students, teachers, citizen scientists in the GLOBE community as well. So take it on, Dorian.
Hey, thank you so much. And boy, just you know, just listening to Yashraj present, listening to his enthusiasm, and you know, watching the ways in which he shares and tells his story is just nothing short of incredible. I have had the opportunity, the privilege of working with him ever since the GLOBE annual meeting when he reached out to me. And that's kind of part of the story that I'm going to quickly tell you about lifelong learners. So it's really neat when you take old people like me, a lifelong learner, or mature people, the jury isn't out on that. Old people like me, lifelong learners, and you take these amazing young folks like Yashraj, and you see, you know, the kind of energy that can be created. So one of the things that I'm going to start focusing on with the GLOBE program is how to bring lifelong learners into the GLOBE family. What I want to show you is a little bit of a video that we created.
The outdoors appeals to learners of all ages. We found that retired individuals are very interested in being citizen scientists.
Okay, I'm just going to skip ahead here.
The outdoors appeals to learners of all ages.
I want you to meet.
We found that retired individuals are very interested in being citizen scientists. So many of us lifelong learners continue to learn and contribute to a wide variety of projects and be involved even after we retire. I had the opportunity this past spring to develop a virtual 6-week course for the Osher Institute.
Good. Now skip it ahead some.
Research and make a meaningful contribution. Spending time.
I just want to introduce you to a couple
of the course
participants
are helping to study our home planet. Welcome, Rosemary and Suzanne. Thank you for joining us today from Hawaii. I did so enjoy working with both of you this past observer course. It was a real honor to be able to explain the many ways tools to collect data from the ground. The Osher course focused on enlisting Osher GLOBE course in the first place.
Thank you, Dorian. This is my first term. It was the first term that I was participating in the Osher Lifelong Learning with the University of Hawaii. And so I was intrigued by the NASA GLOBE Observer description of the catalog, but I wasn't quite sure if it was going to be too technical for me or if I could really contribute. So what really persuaded me was when I participated in the open house that UH offered, and you were there doing your outreach, and your enthusiasm and making it seem easy and fun and accessible really persuaded me to take the course.
Same question for you, Suzanne. It's very helpful to us to know why lifelong learners want to help with these citizen science efforts.
I actually have a Bachelor of Science in Tropical Agriculture from UH. And although I don't work in science, I'm always interested in it. And that's why I thought this would be a great way to participate.
All right, so I'm going to stop it there, but it just kind of gives you a flavor for, some of the richness and some of the potential opportunity that we have in working with lifelong learners. The next steps for scoping out this interaction is going to be having an advisory board and inviting some people, say from SciStarter, perhaps if I can find someone from AARP, Association of Retired Persons, kind of shaking the bushes to see who are some engaged stakeholders who might help to brainstorm and talk about best practices, look at the various networks that already exist. Then, of course, a big part will be networking, reaching out to people that are in these existing networks and finding out what their kind of interests might be, what their audience might find most useful. Then there's going to be two prongs that are going to be very important: how to initially engage these lifelong learners, taking again those existing structures, like I was showing with that Osher course, taking an existing university program that's focused on lifelong learners and meeting them there, having webinars. And then a big piece, as we all know, because we're hanging out here on this webinar and we've hung out for now almost 2 hours, is how to sustain that engagement. How do we keep the ball rolling and keep lifelong learners engaged? Perhaps a monthly newsletter, which is something that they asked me for with the Osher group that I taught in Hawaii. Perhaps creating a team, maybe having a web page on the Globe site that is, just focused or has an emphasis for lifelong learners. Some special events. I think it would be super to find ways and develop best practices and even a networking capacity to have lifelong learners interacting with local schools and helping them to go out and collect the Globe data, perhaps even taking them and working with them on IVSS projects, and certainly helping them to collect data. So just some ideas. There's my email. If you have any ideas, if you might be interested in the advisory board, if you feel like learning more, this is the beginning of this adventure. So feel free to reach out.
All right, thank you so much, Dorian. Does anybody have any questions for Dorian? I saw that Rama in the chat was asking about, she wants to know, they want to know the details of the lifelong learners, and I put your link back in there of the YouTube video.
Thank you.
But I don't know, Dorian, if you want to throw your email in there for Rama,
Sure.
just so she can contact you if she wants to know more information about that.
Absolutely. And of course, we want to take this around the world. Globe is a global project. So, having some folks from other countries who can help to then give us ideas and ways and be a part of this project and reaching out to lifelong learners in your communities would be wonderful. So thank you.
And Dorian, please check out Larissa's comment in the chat about it. That's great stuff.
Oh, thank you. Yes,
So,
we don't want to
okay.
leave anyone behind. You bet, Larissa. That's the joy now of having this Globe Observer, app and the tools. It makes it just so accessible, and it's pretty exciting stuff.
All right, so let's in the last few minutes here, I'm going to go back to sharing my screen again. All right, so quickly, there's a lot of stuff on here, but looking ahead to year 4 of the Trees Around the Globe Student Research Campaign, we're focusing on, of course, the trees, land cover, and greenings. But as I mentioned earlier in the webinar, we're focusing on the 6 globe regions for the webinars. Right now, we are in the Asian Pacific region. And as Peter Nelson mentioned earlier in his discussion with the data, with the 2 major tools, online tools that we're going to be using, we're gonna kind of build momentum with each region as we go, and then by the end of year 3, around September of 2020, year 4, the end of September 2022, we will hopefully have this great collection of data using these tools, visualize the data using these tools for all the globe regions. So what this doesn't mean is we're not going to, hopefully we will have some presenters. We will definitely have some presenters from, each one of these regions, during these webinars. But, it doesn't mean that, because we're focusing on this, the other regions, like for instance, like December and, we're focusing on the Africa region doesn't mean that it only pertains to Globe Africa. It's just that we're focusing on that region for basically our, our discussion for the webinar, our topics for the webinar. And then also what we're going to have, and we're in discussion with the other campaigns, is we're going to be having some joint webinars with each of the other campaigns: Mission Mosquito, the Urban Heat Island Effect Surface Temperature Field Campaign, as well as one that many of you are part of, the European Phenology Campaign. And one thing that we're going to get back into are intensive observation periods. You might have remembered back in year 2 of our campaign, we had basically quarterly intensive observation periods where we focused on taking tree height, as many tree height observations that we could within a month time frame. Okay, but what we're going to do here is we're going to add on to that, and because we didn't do it last year because we were told that we were basically directed by NASA and the Global Implementation Office, we can't really have these intensive observation periods where we're telling people to go out and take all these measurements during the pandemic. So, what we're going to focus on here is, coming up, we're going to be discussing this with the other campaign leads to, for these cross-cutting intensive observation periods. For instance, for a month-long period when the European Phenology Campaign folks are out there taking greening observations, and we hope to do this specifically, in the springtime, where they have their spring campaign. The European Phenology Campaign has their spring, green up part of their campaign, where we're going to focus on, when they're out doing this, take some tree height observations, take land cover observations as well. So we want to have those cross mission, those cross mission collaborations with this, and that's a combination of these joint webinars and the intensive observation periods. And then one thing that we've done pretty well, but not as well as we should as a full campaign, is to focus on ways to get students from different Globe regions and Globe campaigns working together to create joint IVSS research projects. I know that a lot of them come from specific countries. For instance, last year we had a bunch coming, as part of the campaign. They came from students in Thailand who are working together, students in Croatia who are working together, students in, Italy working together, in Oman. Okay, we had all of these, but really what we want to focus on too is, how do these students, how can they talk to each other about the data they are taking and then create some IVSS research project? And we're hoping by splitting these focuses for the webinars into these regions, and I know everyone from each region cannot be at every webinar live because of all the time zones and everything. We understand that, but we really want to get that ball rolling as to how we can best have the students from different Globe countries working together. So let me go ahead and stop. Oh, one last thing. As a reminder, next campaign webinar is Tuesday, November 16th at 1 p.m. Eastern Time, 6 p.m. UTC, and it's going to be introducing the Trees Around the Globe 50 Years of Data Challenge. How has land cover and tree height changed in your location in the last 50 years? And, a main part of this webinar will be, Peter Nelson really, focusing in on those 2 specific tools that we want to focus on. And we're going to have, a focus on Asia and Pacific, but we really want to showcase these tools, because we know there are a lot of online tools out there that you can get lost in. Okay, so we really want to focus on these 2 tools, and those URLs are in the chat as well. If you have to scroll back a little towards the beginning, but those URLs for those online tools are in the chat that Peter's really going to focus on. He's going to hammer home next time that these are the ones we want to focus on, because, as I mentioned, we don't want to get lost in too many different online tools because there are so many of them out there. So does anybody have any last minute questions, comments, concerns? I'm glad all of you could be here. Someone had to drop out because some have, as you know, our webinars always go very long. So, but we have lots of people who had to get to class, and, or teachers who had to do other things in other meetings. But this, as was mentioned earlier, this recording will be available later today. I just have to wait for Zoom to process it and get the link, get the recording to me. So that's just, we're all in the hands of Zoom right now until we get that link up there. Then I will throw it on YouTube and then get it up on the webinar page directly. And then I will send an email out when that recording is available. So I don't see any other questions in the chat. So thank you all for being here. And that's good. Peter, do you want to unmute say that out loud in case people don't see the chat?
Gladly. So, to help you guys all start thinking about what we're doing this year, is what do you think the average tree height is for the region we're going to focus on coming up? And we're going to sort of take a tally, and this is a great hypothesis test, right? What do we think that this is? And is the model actually right? Is that reasonable? Can we calibrate ourselves? So that's one of the fun things that we'll be able to do coming up, is challenge ourselves to actually think about the diversity and the differences between regions. So be thinking about that, and we'll have hopefully give you some tools to be able to answer that type of question in our next webinar coming up in November. But we've shown you ways to get that answer if you want to get a jump ahead. Lots of resources on the website, but you've got a month to kind of think about that, and we hope to see some good answers, and we'll bring up some statistics and talk about some math as we do this. So we're really looking forward to you joining us, not only this coming up, but over the next year.
All right, that is a great place to end this webinar. Thank you all so much, and we will see you next month. Take care, everyone.